Welcome to the Copperfield Electric Podcast. We're jumping straight into a technical mission today that is, well, absolutely essential for any homeowner thinking about the future. We're doing a deep dive into electrical panel upgrades. Specifically, we're dissecting the sources our listener provided, all focused on that critical question. How do you plan these upgrades when you're anticipating future home additions? An ADU, a room expansion, or even just high-demand tech?
And our goal for you listening today is pretty simple. We want you to walk away knowing exactly how to handle this, moving beyond just the basic definitions. We'll show you why the electrical panel is really the fundamental bottleneck in any major renovation, and how smart planning ensures both your immediate safety and your long-term capability. This is the stuff you really need to know before those architectural drawings are even finalized.
Okay, let's unpack this. We're drawing the foundational insights today from the team at Copperfield Electric. They operate as a dedicated 24-hour electrician in Orange County, and they specialize in exactly the kind of planning and complex execution we're talking about.
And that specialization is so important. They are fully licensed, bonded, and insured. The license number is #1094740. Which means they meet that essential checklist for anyone doing complex, high-voltage work in your home. They're focused on panel upgrades, new construction, including those accessory dwelling units, ADUs, and EV charger installations. It just highlights their expertise in services that demand major panel capacity.
And we'll get into their service commitment a bit later, but for now, let's connect their specialty ADUs and EV chargers directly to the foundational problem here, the limited capacity of our existing panels.
Right. Those specific projects are the biggest triggers for this conversation. You might be in Southern California, maybe Irvine or Newport Beach, planning a high-end addition. Or maybe you're in an older area like Santa Ana or Anaheim, where the homes were built decades ago.
Yeah.
The reality is, if you have an older home, you're almost certainly running into an outdated panel structure.
Okay, here's where it gets really interesting for me, because the sources emphasize that the panel upgrade isn't step 5 in the plan, it should be step 1. Why must upgrading the electrical panel be the very first thing you do before you even lay the foundation for a new room or a detached garage ADU?
The problem, well, it boils down to physics and cumulative demand, or load management.
Yeah.
When you add a room or an ADU, you're not just adding a couple of light switches. You're adding HVAC zones, new kitchens or kitchenettes,
And entertainment systems.
entertainment systems, dedicated laundry setups. Each of those additions exponentially increases the total current, the amperage your electrical system must safely handle.
And if you try to push that new demand through an old, undersized system, what happens then?
You create a guaranteed bottleneck. Think of your existing wiring and panel as maybe a 2-lane highway. When you add a whole new neighborhood, you suddenly force rush hour traffic onto that Highway 247. Your circuit breakers start tripping frequently because they're doing their job. They're trying to protect overloaded circuits. But beyond the inconvenience, the sources really stress the critical safety consequence.
So we're not just talking about resetting a breaker anymore. We are discussing an actual fire risk.
Precisely. If that system is continuously overloaded, the internal components, the breakers, the bus bars, the wiring inside your walls, they're all generating excessive heat. That constant overheating degrades the insulation around the wires, and that drastically increases the risk of an electrical fire. Upgrading the panel to a higher capacity is the non-negotiable step to ensure the home stays safe and vitally compliant with modern building standards.
And compliance, that often means changing the baseline capacity, right? I know so many older homes are still stuck with those 100-amp panels. Is 100 amps just fundamentally insufficient for a modern home that's planning any kind of addition?
It is almost certainly insufficient for future planning, yeah? A 100-amp panel was perfectly fine when homes had, basic appliances, maybe a window AC unit, and very little tech. But think about the cumulative load of today's devices. A modern air conditioner, an electric range, maybe a tankless water heater, and then you add a high-speed electric vehicle charger, which alone often requires a massive 40 to 50 amp dedicated 240-volt circuit.
Wow, 50 amps just for the car.
Exactly. When you factor in the base load, the lights, the fridge, the computers, everything else that's running, that 100-amp panel is immediately oversubscribed. To meet modern standards and to support future expansion, upgrading to a 200-amp panel is, well, it's the typical required minimum. That shift essentially doubles the highway lanes for your electricity. This brings us to a really crucial point mentioned in the sources by Rene Hernandez. The planning has to come before the work. So this raises an important question. How does an electrician figure out if 200 amps is enough? Or if, maybe you need even more, say 400 amps?
Right, that initial assessment stage seems like where the real complexity is. A licensed professional doesn't just guess, they perform a comprehensive load calculation. They're looking at square footage, the total number of circuits, and the draw of all the planned major appliances. They're calculating the total power the home will use at peak capacity.
And here's where we get into a deeper insight for you, the learner. They don't just add up every single appliance's maximum rating, they use what's called a diversified load calculation. This calculation assumes that you won't have your oven, both clothes dryers, the air conditioner, and the EV charger running at absolute peak all at the same time.
So it's not simply the full connected load.
No, no. If they planned for the full connected load, you'd probably need a small power plant for your house. The diversified calculation lets the electrician determine the realistic maximum demand, but they still have to plan for the worst case, most common scenario. If that calculated load exceeds, say, 150 or 160 amps, then the upgrade to 200 amps is a non-negotiable step. They have to ensure that if you plug in your EV and turn on the AC, the system still has a safe margin.
That makes perfect sense. The emphasis then is truly on planning for demands that might feel passive but are electrically intensive. We're talking about future demands like fully converting to a smart home, adding a big induction cooktop, or just those general power needs from future room additions.
And let's be specific about those high-demand devices, because these are the culprits that really push you over the edge. An EV charger, as we said, is a huge draw, but a large, modern central air conditioner unit can pull 30 to 60 amps on its own. And if you swap out a gas water heater for an electric tankless unit, wow, that might require 2 dedicated 50-amp circuits just for heating water on demand.
So if you're already running an older 100-amp service, just adding one of those 240-volt appliances, the AC, the tankless water heater, or the EV charger, is probably enough to force the full 200-amp upgrade right away before you even think about the addition itself. Okay, so once the assessment is done and the need for 200 amps is established, what does this all mean when the licensed electrician arrives on site? What's the actual physical process of upgrading the electrical panel? It's more than just swapping out a steel box, right?
Oh, much more. The process involves 3 critically detailed steps, and they must be handled by a licensed professional. Step 1 is the comprehensive evaluation of the existing system. The electrician isn't just looking at the panel. They're inspecting the existing interior wiring, the condition of the service cables leading to the house, and the grounding system to determine exactly what needs replacement for a safe installation.
And then comes the actual replacement of the panel itself.
Correct. Step 2 is replacing that old, undersized panel with the new, larger 200-amp panel. This involves intricate internal rewiring and making sure the new circuit breakers are correctly sized for all your existing and planned circuits. But critically, Step 3 involves the service cables and the meter socket.
Right, because if the new panel is rated for 200 amps, the cables bringing the electricity from the utility pole have to be able to safely carry 200 amps too.
Exactly. Many older homes have cables rated only for 100 amps. If you upgrade the panel but not those service cables, you've essentially just installed a larger container that's still being fed by a tiny pipe. And that leads to overheating risks outside the panel itself. Replacing those main service cables and the meter socket is often the most time-consuming part of the job, and importantly requires coordination with your local utility provider.
Okay, wait. If we have to replace those main service cables and coordinate with the power company, doesn't that add a lot of time and red tape to the project? And what about inspections?
It absolutely adds complexity and time, which is why that professional planning is so paramount. The electrician has to pull the necessary permits, coordinate the power shutoff and reconnection with the utility, and ensure the local municipality inspects the work. This leads directly to why professional expertise is mandatory here: compliance.
And why is compliance so key? We keep mentioning it, but what are the actual rules they're following?
Compliance is the ultimate safety layer. The professional ensures the upgrade meets the mandatory National Electrical Code, the NEC. The NEC is the foundational rulebook for safe electrical wiring and installation across the entire country. Only a licensed electrician understands and adheres to every local amendment and national standard. This is what protects your system from future hazards and ensures that it's properly sized and grounded.
So if a DIY project or some unlicensed contractor tries this, they might save a few dollars up front, but if they fail to adhere to the NEC or local codes, the city inspector won't sign off. Insurance might deny a claim if a fire happens, or much worse, they might create an unseen hazard.
That's the real risk. The NEC requires specific wire gauges, specific breaker types, and precise grounding methods to prevent common failures like shorts. And crucially, to ensure that the overcurrent protection, the circuit breakers, will actually trip when they're supposed to. Safety is the foundation. The ability to power your new ADU is simply the benefit that follows.
So what does this all mean for you, our listener, planning your renovation? We've covered safety, compliance, the load calculation, the complicated process. What are the big aha moments we should walk away with here regarding the value proposition?
Well, the synthesis is that the panel upgrade is an essential investment that enables all your other home improvement projects. The value of choosing a licensed professional, like the team at Copperfield Electric, is that they remove the guesswork from that load calculation. They ensure the new 200 amp service will handle not just your current plans, but anything you might add years down the line. They guarantee compliance, which protects your investment and the safety of your family.
And the sources noted that engaging in troubleshooting and diagnosis with a professional early on can save you money in the long run. I have to imagine that's because fixing a failing, overheated 100 amp system later costs far more than just proactive planning now.
Absolutely. The professional ensures power stability, preventing the costly downtime and damage that can come from constant breaker trips or, worse, those latent fire hazards. The panel upgrade is the enabling infrastructure. It's what allows you to confidently move forward with projects like EV charger installation, high-efficiency appliances, and major home additions, all without worry. If you live in an older home and are considering even a moderate increase in your electrical use, I'd really encourage you to stop and find out your current panel rating. Is it 100 amp, 150? Understanding that starting point is the most crucial piece of information for budgeting and planning your next project.
That's a great practical, immediate step. And for a final provocative thought for you to mull over, we discussed that high-draw 240-volt devices are the biggest culprits in forcing an upgrade. So if you only had one single high-demand appliance to add, which one, an electric vehicle charger you'd use daily, a new electric tankless water heater with its consistent heavy draw, or a new high-efficiency central air conditioner with its seasonal peak draw, which one would most certainly require that immediate, unavoidable jump from a 100 amp panel to a 200 amp panel, the one that would force you into this crucial upgrade right away?
That's a great question. Sustained draw versus peak seasonal draw.
Exactly. Something to explore for your next project. We hope this deep dive has helped you quickly gain the knowledge needed to approach home additions smartly and safely, realizing that the electrical panel really is the heart of the renovation. For more information on electrical services or to schedule an assessment, you can reach out to the experts using the number provided in the sources. That's 626-622-9694. We look forward to guiding you through the next deep dive.